Hello. So thank all of you for sticking around to the bitter end of the conference and seeing this talk. I'm going to be talking about real-time NoSQL, but probably maybe, I don't know, different than what you might think it's about. Anyway, so I work at Blekko, and if you haven't heard about us, we're a new web-scale search engine, like Google, only smaller. And we've been launched and in production for 2 years now. And by the measurement of the big companies out there, we have a small cluster, but to most NoSQL people, we have a big cluster. We have currently 1,500 servers with 20 petabytes of spinning Rust and 1/2 petabyte of Flash. And we run our entire search engine application on top of a homegrown NoSQL system that has some interesting features that allow us to use the Flash and disks together and compute in the database and all sorts of stuff like that, which I won't talk very much about. So what are the problems that I'm out to address? So if you're familiar with a lot of NoSQL solutions in the Hadoop family, a lot of them are used mainly for sort of offline or batch operations, right? You take data that maybe comes from someplace else, maybe even a SQL database, you put it into Hadoop, you go off and do some processing on it, or log processing. Say you take logs that come off of a bunch of different servers, put it into Hadoop, do processing. And when you do this frequently, you don't mind if you have short outages or even outages that are a few hours or a day. So that's very different from having a real-time system where users come to your website and they expect to get an answer for their search in 300 milliseconds. Another thing that's challenging about this with the conventional N-tier model where you have sort of front ends and business logic machines and then a database at the bottom, a lot of these nodes can be stateless, and that makes monitoring and debugging the system very simple, because if something fails, you shoot it in the head, and then it doesn't get used anymore, and you didn't lose anything, and so life is good, right? As long as the database stays up and the thing that sort of parcels things out to the load balancers is up, then your website is up and you have no problems. However, if you take sort of the equivalent NoSQL database that sort of looks like ours, you end up with distributed storage on all of your nodes, and so you actually care that almost all of them stay up. So there's very few stateless things hanging around that you don't have to worry about. So you get to worry about everything instead. So if you set up sort of the usual monitoring systems, you run out and you download Nagios and install it out of the box, you will discover that with thousands of nodes, it very quickly becomes too noisy. And so any engineer who's not required to listen to what's going on will, of course, send that off into a folder that they will never read. And all of your other poor engineers who are required to read what's going on will quickly become overwhelmed. And if you're trying to run, again, a website that does stuff in real time, you have to be very reactive when there's a problem. You have to respond to things. And you can't do that when there's a pile of email in your box. And in a system that is like a lot of the ones that people at this conference run, where you have active development going on and it's not really mature by any sense of that word, there's lots of collective fail that's available to you. So in a mature system, usually you don't end up with memory leaks that pop up out of nowhere and suddenly cause hundreds of nodes to run short on memory and begin thrashing. But that really isn't that unusual in an environment where the entire system is under active development. So with all this collective fail available, there's a lot that you need to discover with monitoring and run out and fix very quickly. So as I give this talk, you'll notice that it consists of sort of two things: patterns that make sense to everyone in sort of this situation, and then things about my environment. And these two are intertwined in most things that I say. And the main takeaway that I expect you to end up with, I hope, are patterns which you can apply in your own environment. And I'm actually interested in hearing stories about sort of major things that I'm missing in terms of patterns in this area, because I'm writing a book. And so I'd love to hear additional stories and see what I'm missing out on. So first, we'll have to cover what you're missing out on. So at this point, in many talks like this, you have a slide like this, which has a lot of text on it. And since we don't have any Java in our system, So happy. Okay, so when you're doing monitoring, there's a few very basic things that a system needs to do well. And you know, I never did any of this well until I got one of these, you know, phone things, and all of a sudden, you know, if you're reading email on your phone, you open up your email, and you know, it does a really great job of getting, you know, the sender and then the subject and the first, you know, few lines maybe of the email in front of your face. And so if your poor people who are reading your alert emails have to deal with that, it's an opportunity actually to help make their lives easier if you actually hoist everything up to the beginning of the message that you can. So the subject of an alert email ought to contain the most important info about it, and the body of the email should contain enough information that you shouldn't have to actually go log into the node which is complaining to diagnose most of the failures. And you would think that this would be normal in this environment, but it actually isn't. If you take Nagios, for example, out of the box, it will bury the lead very deeply down and really fail to do a good job of helping you diagnose things easily. An additional pattern that I find to be incredibly useful is to take, whenever you have something that realizes there's a problem, usually it looked at some statistics about the system, and it has an opportunity to sort of log all the information about what was going on somewhere. And usually that's too voluminous to put into the email, but that doesn't mean you shouldn't write it into a file in temp. So, you know, it'll, depending on how you're configured, it'll disappear within 30 days, so you don't have to worry really about how big these things are. And I call them turds. And I love it when all my alerts leave turds behind. So a turd ought to contain sort of anything that is useful to diagnose the problem that might disappear by the time an admin comes by to look. So if you have, you know, high load or low memory, having the output of PS and a turd is very handy because it could be that all that's disappeared by the time you know, you come by, and then you're like, oh, well, you know, it looks fine to me. But that just means you totally miss the opportunity to debug what happened. So this is part of the basics of not looking like an idiot, where the engineer sort of developing the app is like, you know, why did the website fail? And oh, well, I don't know, this node had high load, something went wrong, and the you know, engineer working on the app says, oh, well, what happened? So I could fix it. And the ops guy says, well, I don't know. So you look like an idiot. So don't look like an idiot. So problems clear up, right? And the turd helps you figure out what went wrong. And if it doesn't, then you can enhance it for next time. Actually, if I can give you an interesting example. You know, TCP has a bunch of different states, and you can count the number of sockets in different states. And it's usually a bad situation if you have a lot of sockets which are stuck in the finweight 1 and finweight 2 states. So randomly, when I was doing alerts for blekko sort of for the first time, I decided I would count these up and have alerts on them. And it turns out that what this did, it didn't go off for years. And when it did go off, what happened is that someone using our database was sending a very large number of messages, which happens to also be a bad idea. So it was sort of a speculative alert. And it can be annoying to have speculative alerts when you don't know if they're really a problem, because it turns out if it goes off all the time and it's not actually a problem, then you're sad and you turn it off, and it did nothing but waste your time. But this time, when it went off, it actually was useful. And it was very easy to see because the turd contained the output of netstat-tanp. So as a result, it was really easy to see that, hey, all the finweight 1s are actually sockets from localhost. So it was really obvious what was going on immediately. And this has actually come up twice. And both times it was pretty easy to go figure out which daemon the accesses were coming from, and go to and give that engineer a shake, and they could go fix their code. A second situation where this can really save your bacon is when a node hangs without a sort of any external evidence. And when a node is sufficiently hung, you can't do anything but reboot it, which of course destroys most of the useful evidence. So if you're lucky, and depending on the way it hung, you'll end up with some turds. Either they were generated a few minutes before the hang and they're useful, or else they actually happened after the thing hung. So I find in my environment that occasionally I have nodes that run out of memory, and they run out of memory so quickly that my custom OOM daemon is unable to catch it and kill the right thing, and the system OOM daemon also fails to do anything useful before the node hangs. And typically, this happens still slow enough that I end up with a turd, and therefore I'm able to go and sort of point a finger at which daemon was the one that's out of control, and that helps people find it. And that helps me not look like an idiot, and I like it that way. So a third basic that has a pattern that could definitely be improved is cron jobs. Many alert systems use cron jobs, and if not, then you've got other sysadmin stuff that uses cron jobs. Your application might use cron jobs. And the cron system really sucks because it has this environment in which people constantly write and test cron jobs, and then they put them into the cron tab and they fail because the environment doesn't look like a logged in user. And also the email doesn't necessarily go anywhere, and when it does, it says the same damn thing whether or not the thing succeeded or failed, right? It doesn't say anything like, oh, your exit status was 4. It doesn't say, oh, and these lines are printed on standard error. It's just an email. And so in most places, people, they look through the email every day trying to find if there's any error output hidden in there somewhere until their eyes glaze over, and then they stop reading the email, and then the error occurs, right, the next day. And so in order to avoid this, write a wrapper for your cron tab. This is not very long. Set up a normal looking environment as if it was a logged in user. Capture the exit status and standard error output. And if you have things on standard error or it doesn't exit 0, then send it to a different email address and if it succeeds. And that way you can only look at things that fail. And this is very useful. Just to give you an example, engineers are not very good at error-proofing cron jobs. And so, for example, the engineer, blekko has data related to users and these things called slash tags that we have, which are basically vertical search engines within our search engine. And it's a fair bit of data, and we back it up every night on the off chance that we have a bug that destroys too much of it, and we'll go and restore some of it. And so the engineer who wrote that cron job, he's not an ops guy, right? And yeah, so the cron job was not particularly error-proofed, and it's a usual deal where I looked at it, I filed a bug against the engineer, and of course it's 2.5 years later and he hasn't fixed it. However, when the job goes wrong, it prints out stuff on standard error. It exits 0 always. And also, by looking at the amount of runtime it has, if it's too short, that's bad. And if it's too long, that's bad. And if it falls into an intermediate range, then it's good. And so it was nice to see that among all the features that after 17 years of having a wrapper at the last 5 jobs I've had, finally I had enough features in the typical wrapper that I could actually engineer around the engineer and make his cron job run reliably, even if he wasn't interested in having good error handling within it. So the little extras that are handy is a little bit of syslogging for success and fail. Cron carefully logs that when it starts things and doesn't tell you anything about when they ended or how they exited. And the limits on runtime that I mentioned, that if something runs too fast, usually that's bad. If something runs too slow, that's also bad. And then finally, some cron jobs need interlocks, and programmers are not so good at handling, at inserting those, so having them in the wrapper can be very handy. So that takes care of a few basic patterns that perhaps are new to you. Now on to the ones that are sort of cluster-oriented. So I have 300 machines in my cluster, right? And if 57 of them start throwing the same error at the same time, would you rather have 57 emails or 1? And the answer is 1. But you'd be amazed at how many folks have yet to figure out how to do this. So, right, the subject, instead of saying, hey, one host had a problem, it says, hey, the Aries cluster has 57 out of 308 hosts with high load. And then in the body, you have 57 summary lines, one for each of the hosts that's having problems. If you're clever, you take what would have been the subject lines for the 57 separate emails and put them into the body at the top of the single email. And then at the bottom, you can have a PS output from one example node for this, because that's the appropriate thing for this alert. And then you also have a turd on every single node that you could look at. And this makes your life a lot easier, right? In a lot of environments, not everyone is responsible for every cluster. The engineer who's goofing up and causing all the problems are usually only working on a cluster or two, right? Your development clusters are very different from your production ones, blah, blah, blah. And this way, you can sort of route the alerts by cluster to the right people for each one. And that means all the appropriate people get informed and they don't get mail bombed. And so hopefully they'll continue to read the emails instead of ignoring them. One thing that I haven't fully implemented even in my environment is clusterizing the cron job fails, right? So the cron job wrapper, when there's a failure, can easily send you 308 emails if you deploy a bad cron job. This is pretty much our last source of email floods is cron jobs that ought to be clusterized. I'm going to mention Nagios a fair bit through the rest of the talk because we happen to run Nagios at Blekko, and this is not an endorsement of Nagios. I hate Nagios. The only reason I use it is because over many years, I have determined how to beat it into submission and make it do what I want. And I have not gone through this process with any other system. If you actually know something that doesn't suck, please let me know later. Elsewise, yeah. OK, so how do you beat Nagios into submission? So first, Nagios has scaling problems, and it doesn't work at thousands of nodes. And the classic Nagios way to solve this is to chop up your system into small clusters and have a Nagios instance to monitor each. And then you build a hierarchy of Nagioses that pass messages around. And this is just the dumbest idea I've ever heard of, because the thing isn't scalable, and so turning it into a tree to make it scale is just not a reliable way to produce a good system that informs people quickly of things. So in order to fix Nagios so that it sucks less, the first thing to do is to use passive checks instead of active checks whenever possible. And what you end up with this is basically running a large number of cron jobs, which is why I mentioned cron job wrapping and floods of cron job emails. Of course, you have a few last active checks that you have to make sure cron D is running on the nodes, right? If cron D stops on the nodes, which the Linux cron D is of such high quality that if you have hundreds of nodes, you'll quickly notice that several times a year, one of your nodes won't be running cron D anymore, and there won't be any sign as to why it's off. So you need to check that cron D is running in order to keep the thing reliable. And sort of the why behind this is the active checks in Nagios are single-threaded, and they get way behind, especially when things start going wrong. So you can build your lovely Nagios hierarchical system that has one Nagios server for every 100 nodes and a hierarchy of this and that, and the thing will still screw you over because it'll look like it's running OK until the minute that you have a lot of problems on a lot of the nodes, and the minute a lot of alarms start going off, it starts running slow, and it gets behind, and then it's not helping you anymore if it's sending you stale information. So don't do that. OK, even if you use passive checks in SCA, changing the Nagios state, writing into the Nagios state is expensive enough that you have to be careful not to send duplicate OKs in. So your little cron jobs need to remember the last thing it sent into Nagios. And and what we do is if it's an OK, of course these messages can be lost. Basically, every node has its own personal time within 3 times a day that it will send in a duplicate OK in case the system, that alert was marked as being failing because the next OK message was lost. You don't want that to go on for days. So every 8 hours, we'll send a duplicate OK into the system to make sure that it really is OK. And that seems to work. And along the way, you'll discover that by the time you're done, you will have replaced every single check that is distributed with Nagios because all of them actually suck. and so there's a fair bit of additional infrastructure you end up building in order to remember the state and remember when I should send a duplicate OK and so forth and so on. And so this is 10 years of pain with Nagios. Nagios sends emails, and I described a pattern for what emails ought to look like with the stuff in the subject and the stuff in the body. And Nagios fully supports changing the stuff in the body, but of course doesn't support changing the subject. But you can fix that pretty easily. So there's a single script that sends Nagios emails, and it's not too hard to go and hack that up without having to worry about the rest of the Nagios code. And so the trick we play is we put strings into the body of the message, which then the script deletes out of the body and will hoist up into the subject. So for example, this square bracket subj colon something close square bracket is the syntax that we use to throw something up into the subject. So this would be a single node alert. Hey, my load average is 153.6. And then that gets sent into the Nagios server with an NSCA update. No notification is sent because this is a clusterized alert. So when the cluster alert runs as a cron job on the Nagios master, it will look in the live status database for all 300 nodes in the cluster for the load average alert. It'll find out who's gone, who's critical, who's warning, who's OK. And if anyone is critical, it's going to send out an email saying, hey, 1 out of 308 nodes in my cluster has a high load average. Doing this, you'll quickly discover that Nagios has a length on the largest size message that can be passed through in SCA. But by this time, you're on a roll, and you refuse to be defeated. And so in fact, what you do is write a file into temp on the local node, pass your node name colon the file name in the body of the email to the script, which will then go fetch it and put it into the body. And that allows you to have emails of arbitrary size. And this allows you to do lots of additional stuff. For example, so Nagios has a nice UI, but it's a pain in the ass to click through, and it's very slow when you have thousands of nodes. So it's handy to go immediately to the right place, which you can do. There's a link, and it's very easy to figure out what that link is in your code and put a link into that damn email so that the user can click through, the admin user reading the email can click through to exactly the right place to acknowledge the problem or to put the host into downtime, et cetera, et cetera. And we also put a link to our wiki that explains what the error is, since there's enough different kinds of emails. I don't expect everybody to keep all the details in their head. And so we have a link to our wiki entry for every single alert that basically allows us to inform ourselves when we forget what's going on. And especially for the engineers who are not ops people who sometimes get these emails, having that is a lifesaver because usually it's new information to them. Blah, blah, blah. A bit more there. So so clusterizing Nagios, right? So I have all the per node alerts, right? That that the load average is extremely high, or I'm very low on free memory, or I'm beginning to swap. And I take all those alerts. You have them run as cron jobs. Their notifications are disabled. You have a per cluster alert per node. That per node alert type, right? So for the load average alert, right, I have one for every single node in the cluster that runs on that node. And then you have one cron job that runs on the Nagios master, which queries the live status database for every node and finds out how many of the 308 are firing. If it's 0 of them are critical, then it just exits and doesn't send an email. But if it has one or more, or whatever it's configured to be, then it makes up an alert email. And thank God, the one thing that Nagios can do is that reading the live status database is fast, because otherwise this trick wouldn't work. As far as I can tell, that's the only thing that Nagios is good at, because the web interface does a lot of reading and it's slow, but this happens to work. And then finally, you need to double check, before you get upset about a node having a critical problem, you need to look and see if it's in downtime, if the node is in overall downtime, because basically you need to give the sysadmins a flexible way to make this cluster alert stop firing. Turning off the cluster alert is a bad idea, because that means you're blind on all 308 nodes because you're upset about one node, perhaps. So instead, you want to be able to put either the entire node into downtime, or to be able to put the load average alert on a particular node into downtime, and that will cause it to stop tickling the cluster alert. And then finally, again, all these are passive alerts, right? So the cluster alert is a cron job that runs on the Nagios server. Okay, so I started at the base level, what should emails be? How do I handle sort of node level things, cluster alerts, and now we sort of get monitoring at the top level. You'll see a lot of people talking about this. So you have user visible metrics. So for us, for example, it's the response time for a search on the search engine, right? The 50th percentile, the 95th percentile, the 99th percentile. So you need to monitor sort of all these to get an idea of how well you're doing. And for us, we also have a combination of both web search, and we do news and blog search and et cetera, dated material. And so we also want to know, is the live crawler keeping up with dated material and updating it promptly? So these are sort of normal things to monitor. The next more interesting is monitoring things about your NoSQL database. So there are sort of two ways to do NoSQL databases. One in which you use sort of conventional RAID 5 or whatever to store your data. And the other way to do it is to keep sort of 3 replicas for each piece of data, not using RAID per se, and having the application handle keeping all the replicas. And so when you do this, you have a repair daemon somewhere that's off making sure that, hey, here's 2 replicas. Oh, I should make a 3rd. And so you need to monitor to make sure that you're keeping up with it. And this is an unusual thing, but definitely worth monitoring. Every NoSQL database is perverse in the way it handles reads and writes in some way or another. So our database prioritizes reading over writing. And so you need to monitor to make sure that writes aren't being too throttled. If they are, then something is more horribly wrong than it's obvious. And that's a very important alert for us to have. And then finally, audit that all the daemons are responsive and running the correct version of software, which is something that's typical in every environment and frequently is lacking. But auditing occasionally can be very handy because having a surprisingly old software version, typically you'll try to do something to make sure that if a node was down, for example, when you push new code, it will not come up and re-enter the cluster without getting the latest version first. But if all else fails, and after the fact audit is a great way to find out what happened. So a dashboard, you should have a dashboard that has lots of fancy graphs and things. And I guess I could show you our dashboard, but really it's not that different from anybody else's. You should have stuff about your NoSQL database in there, however. So not just your application stuff and not just your node stuff, but the database is a thing. And you should pretend like, hey, if I had a single server that had this database on it, what were the things I would want to know and graph about it and go off and graph all of them. It can be really handy to fire alerts based on a stats history that actually goes back a ways in time. And depending on the way you collect these statistics, you might want to do that here, or you might want to do that in your Nagios alerts, your choice. And by the way, there's a new thing coming for pretty display of lots of statistics. And it's sort of a paired thing. Saturnalia DB is the name of an open source project that is capable of efficiently storing large counts of time series data. So they don't mind storing on order 200,000 to 500,000 different statistics that change every 60 seconds. So that is a worthy cluster statistics recording database. And then statmover.com is a cloud hosting service that sort of goes with it. And they have not yet launched yet, but they are about to. And it's the nice, among the database, rather the statistics for clusters sort of offerings, this one looks the nicest to me of any of them. Monitoring your monitoring. So it doesn't take too long running a monitoring system until you realize that the monitoring system can fail. And when it does, you are SOL, because you can't actually see anything anymore about what's going on in your environment. So this is probably one of the biggest, the biggest emergency, of course, is something is screwed up with your network and you're not sure what. But the second worst thing to happen is your monitoring system isn't working and you have no idea what's going on. So the first one will probably take down your website. Second one, the website will look up, but who knows. So for in the Nagios example, you can have multiple Nagios masters and have them cross-monitor each other. Is Nagios up? Is the live status database thingy up? And are the node cronds running? And for the most part, that takes care of making sure that Nagios itself is functioning OK. So finally, we get to monitoring that was a lot of slides till I got to monitoring. So yeah, so you want to monitor that nodes are pingable. The system disk isn't read-only because that's what happens after Linux sees a file system error, is it'll remount the system disk read-only. Is the load average OK? Does yum check update say that we're up to date with whatever repo we're pointed out? Is NTP synchronized to enough things? And do the jitter and offset look OK? Does netstat say that I've got a lot of TCP retransmits or going on, or my queues for accepting new sockets are overflowing too much? What's IPMI say about the temperature of the box, or ECC errors? Is my mail queue small? Blah, 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 blah. This is the usual list. One thing I will add to this as a pattern is the node configuration correct? In a lot of cluster systems, they have the ability to deploy a new node, and they might have the ability to modify a node when it's up, but they may lack the ability to check that a node's configuration is correct. And this is a very handy thing to have, and you should have it in your system if you lack it. You also often need to write code in order to hook up to vendor utilities. So in most of my nodes, I have a thing that is a SATA controller that is designed to be a RAID controller, and the JBOD mode is an afterthought. And so as a result, the smart statistics that you would like to directly access are not always available to you. And that means you're stuck. You go and you give the vendor a kick, and they'll come back and say, oh, yeah, we have all these proprietary tools, and we've got this lovely GUI so you can administer our RAID system. And you're like, what, GUI? And so then you give them another kick, and they come back and say, oh, well, we have this command line tool, and if you run this command, it'll dump out this wad of text that'll describe what's going on. And it'll say, oh, yeah, disk 3 is in predictive failure. And what that means is the smart short test failed. Eventually, you figure out. So you have to hook this into your monitoring system because it's hidden from you. And if you're using the 6-channel on the motherboard adapter, you're used to a pampered life where all the smart utilities work the way they're supposed to. And pretty much any RAID system, you end up doing something extra. Subtle issues in node monitoring, I mentioned out of memory already as being one of the things which is a great evil, especially when it happens quickly. A pattern that I recommend to people, and I see it about half the time, is that you should have your own out-of-memory daemon. The Linux out-of-memory thing that fires, if you'll notice on the kernel mailing list, it's discussed vehemently once every month or two, and they add a new bell or whistle that allows you to go through the list and mark which things you'd rather have die and stupid shit like that. Don't do that. Write your own. Run PS. Look at what's big. Lock the thing into memory, and because you know what's the right thing to kill, and you should do that, right? And you can also fire alerts that way because it knows best when it's about to fire, and so it can fire an alert, and that really helps keep things under control. Another subtle issue is, well, if you have a slow memory leak and you do, your engineers, right? If you tell them they have 96 gigabytes of memory, tend to want to use 95.5 gigabytes of memory for application memory. And if you're unlucky, they want to lock 90 gigabytes of it, which works OK in recent Linux versions, but not OK in older ones. And yeah, so it's very easy to send that machine into thrashing. And so I think the usual solution, and it's not that unusual, I suppose, talking to people, is to configure a little bit of swap. And then basically you try to figure out, hey, a few pages, it's OK if they swap out. But if it's too many, then probably I'm thrashing. And there's no direct way to discover thrashing because thanks to the miracle of mmap, I don't believe that Linux, and I could be wrong recently, but that Linux accounts for mmap reads in the same place that it counts swapping blocks in. So as a result, you can't directly tell if you're thrashing. So you need to look in proc meminfo, and in proc meminfo, you will be confused because you need to add the true number of free blocks in the swap is swap free plus swap cached. And of course, you probably already know that when you look at the mem-free number, if it gets to be too low, that's bad. But all the cached pages are available to be freed. So really, you ought to add that into mem-free before you get upset that mem-free is low. Monitoring logs. So there's a lot of useful information that you can only discover by looking in places like the syslog. For example, you have an application level program and issues that read to the disk. The kernel fires read ahead. Read ahead gets an error. The user application gets success because what they asked for succeeded. And then the user app doesn't happen to read that next block where there's an error. And, or even if it does, maybe it retries and gets it. So you end up with an error in syslog that is never observed by the user level application. So it's very handy to monitor syslog for this. Of course, when you do this, you need to make sure that you only process incremental chunks of the syslog since the last time you looked. And you make a list of everything that's an error. And over time, you accumulate more and more of these. It's handy to parse some errors. So for example, for disk errors, it's really good to know which disk is the problem. On my nodes, right, I have 8 file systems. So I've got 8 disks or 8 or 10 disks. And I have 8 or 10 separate file systems. And so I'd really like to know which one's involved. And I do a different thing, right? If it's a system disk, that screws the whole system. But if it's only one of the data disks, then it's like one of my pet gerbils died. And I don't really care. I just wanted to get it out of the cage so it doesn't smell. It really matters which disk is the one. There frequently are application logs that ought to contain nice fail info. So if you're a properly evil sysadmin, you've figured out how to get stack traces out of the application so that the poor engineers are not able to get off the hook from fixing their busted code. This requires language-specific programming as needed. So for example, there are some hoops you need to jump through in order to convince your Perl application to dump a stack, which you have to look frequently at the C stack. And then the Perl stack can be printed in a couple of different ways, one of which is unsafe and doesn't always work. It has the most info, and it's prettiest to look at. But there's an uglier way to print the Perl stack, which you can suck out of the CGI Perl implementation. And so we print out 3 stacks every time we have a failure of one of our Perl processes. And also, Perl itself, just as an example, generates error messages, which it prints out to standard error when bad things happen. And some of these have a nice warning form where it's easy to parse them, but 800 of them don't. And so I have 800 patterns for Perl errors that I pulled out of Perl diags. And I probably have seen maybe 150 of them happen in reality. And capturing an error once can be very handy because frequently, a lot of bugs, if you only could observe them in action, they could be fixed. And so this at least coughs up a specific error and a specific line number and a specific file. And frequently, that's enough for a programmer to fix something. While you're monitoring logs, one annoying thing that happens a lot is that syslogs or various logs get floods of messages which are enough to annoy you, and so it's very important to watch the file size. If it's going up too quickly, for example, one common way this occurs is if a disk has errors, even though your database or your application may have stopped using it because you told it to, because you noticed the error, it could still be spitting out so many errors that you definitely want to unmount it. And the best way to discover that is just by looking at the file size growing. Log monitoring noise. So once you're monitoring, for example, Perl warnings, engineers may be slow to fix these problems. And the syslogs can also be very noisy too. Pretty much every RAID system, I think, is capable of throwing an error which fails to identify what's actually wrong, in which case, what do? You have to be able to prioritize and silence things on a finer grain level than an entire alert without deploying new code. And this is one place that we're actually failing. And so, for example, we don't do as good of log monitoring as we should because we don't have the ability to silence them and prioritize them and say, damn it, this engineer hasn't fixed this bug, so I'll make sure the email goes only to him, and then I don't have to see that again. We don't have that sort of a system in place yet. I wish I had it, so it's a good pattern. Monitoring auxiliary stuff. It's funny how some of the monitoring you can do looks the same, actually, whether it's a host or a network switch. Network switches have computers in them. They're called the control plane. And they have load averages. They run something like Linux. They have memory usage. You can query it remotely. They have a syslog that they spit out. They come up with all sorts of interesting information, and you should log that and look for it. your PDUs also have logs, and they need to be up in order for power cycling to work, so it's worth monitoring them. So just as an example, our triplet PDUs are very airflow sensitive, and so their computers crash when they get hot. Time monitoring to your NoSQL database. So our database has the feature that it can abandon nodes and disks that are failing. And usually, the first reason you discover there's a problem is because you looked in syslog and you discovered that it was complaining about a particular disk. And so at that point, we can go in and we can either mark it as abandon if it's failing, or bad if it's actually bad. And if it's a system disk, of course, you need to mark the entire node as abandon or failing. This allows a much more graceful recovery. It can take hours for a disk to go from a single uncorrectable read to an actual problem where it throws an error, and that's plenty of time to copy its data off somewhere else. When you do this, it's a very important pattern to record why so that you don't lose it, because you don't really want to have to look in the syslog again to discover why this disk was considered to be bad. And so we actually have files on disk. They're called disk bad and disk abandon, and actually host bad and host abandon. And if you put contents in there of why you abandoned it or why you marked it to be bad, whether a human marked it abandoned or bad, or the Nagios disk checker marked it, then it's very handy information to have in the future. You can't lose it. Our system moves things from abandoned to bad actually when they finish getting emptied, which is a handy feature. So then once you start sort of ignoring things, right, if you're automatically handling an error, so for us, if one of the disks, data disk dies, it's a gerbil, and you just pick it up out of the cage and throw it into the garbage. But you have to remember to go to the store and buy a new gerbil, right? So if we're ignoring these ordinary failures, you need to track what's broken and spit out a report, which you can ignore until you finally decide to go fix things in the colo, which for us occurs about once a week or so. And it's handy to have that info in the files, which help you be able to understand what's wrong when you've forgotten it a week later. There's a magic time in every system's life when it's available for benchmarking. Disks become sad sometimes. They fail to throw an error, but they start running really slow. And the one nice time you can know that that disk is idle and available for testing is right after the node is booted, but before it starts up the database. So that's a very handy pattern for finding things. If you're using the 3 replica system that I described earlier, frequently you'll have dead disks in a lot of nodes. Don't mount them. We don't use fstab for our data disks. We only mount the system disk that way, and the nodes run a script that we wrote that sort of tries to do the same thing fstab does, but it doesn't get upset when it can't mount something. It's just a minor problem. It's not a big deal. So it doesn't have to wait for operator intervention. Your sysadmin tools need to be idiot-proofed and work with your database. So for example, when you want to unmount a disk, it's worth an automatic check and making the admin force it to unmount. If you are destroying one of 2 replicas of a piece of data, or if you're destroying the only replica of a piece of data, right? That's a disaster. That means you will have lost data. Putting things back into service is also a non-trivial operation in a lot of environments like this. So especially fixing a host, you need to make sure that it has up-to-date software if it was down while new software was being pushed. Tail log files is a very handy command that we wrote because it turns out we have like 8 places that we need to look in order to figure out why a host was down when it's suddenly down. And instead of making some poor human log in and type 8 different commands, we sort of scripted it so that you could look at the last 20 lines of the 8 different things, and the most important one sort of at the top. And so that really helps you quickly figure out, because even better than being idiot-proof sysadmin tools, you want your sysadmin tools to be Beach certified. And the reason you want them to be Beach certified is because some poor guy has a pager at night on the weekend, and you should imagine he's on the beach. And ideally, the typical failure should be something that doesn't cause him to have to leave the beach to go take a shower and sit down at his computer. And instead, he's got a web interface that he can use with his phone or iPad or whatever to read alerts and examine logs. And the most common actions that need to be taken, either you've automated them, which we did for the disks, or they're an easy button or 2 for him to look over and say, okay, this is indeed a minor problem. It can wait until the next workday, and so I'll push this button and I'm done. So that's Beach Certified Sysadmin Tools. I mentioned a couple times a 3-replica system. If you go and watch the video of my talk from last year, you'll find out more details than you ever wanted to know about those kinds of systems. If you do this, there's one interesting thing you need to keep in mind, and that's that RAID systems actually do something useful for you. And when you have uncorrectable reads where it thinks there's important data there, and maybe if it tried again, it could get it back and not have to give you an error, and you don't care about that data anymore, you have to write the entire disk in order to get rid of all those sectors and give the smart system a kick to reset the counters. And so this is a utility that you have that you don't have otherwise. Otherwise, you'll end up, basically what happens is you'll return a much larger proportion of disks than usual will be no trouble found, and eventually your vendor will become angry with you. Application-specific debugging. I mentioned these 2 slides because I've been doing this kind of debugging for 17 years, and I have not run into another system that did this. So actually, I'd love to hear if somebody knows if any of the current NoSQL distributed systems do this. So these systems contain a lot of daemons, and they spend most of their time passing messages. So if you integrate debugging messaging into the event loop of the daemons, then you can sit there and basically debug things by hand on the production system. So it can be as fun as running dtrace on a system that supports it well. And it's also nice to be able to collectively command many nodes at once to sort of do the same thing and consolidate the output. So you go look, you're like, oh, gee, what's this variable? And you discover at 307 nodes in your cluster, it's 1, and on one node, it's 2. And it's nice to have 2 lines of output that tell you that. Very handy for debugging purposes. So the messaging types that are really useful, and I sort of started at the top and worked my way down over 17 years. So the first is send me log output at debug level D. And so 1 is normal and 2 is more. And this is always more than you're sending to disk, but you get more verbose as D gets larger. And it's really handy to have an optional grep on there so you can really reduce the network traffic. So if you're looking at some unusual event, you're like, gee, I know I have this warning that has this particular text in it that I'm wondering is going off. So you command all the nodes in your cluster to run at debug level 2, which is required to generate this warning, and then you grep for that string. And then basically very little network traffic will be generated until that string actually pops up somewhere, and then suddenly you know about it. This can be very useful. The second one is to be able to examine data structures in the running daemon. This is easier in Perl because objects are hashes. So while that's usually considered to be a minus, in this case it's a big plus. And then in the current system, we had some interesting memory usage bugs that we had. And so it's very handy to be able to look and see how many counts of various types of objects and whatnot, or what recent events, if you're an event-driven daemon, what events have you processed and how long did it take you to process each of them? Or even better, if you're trying to chase down high latency event problems in your daemon, to be able to say, hey, look, if you have any event which takes over this amount of time, then dump the past events. These can all be very handy, although they do get more esoteric as they go down. And the details in your system will be different for the bottom ones. But the top ones, I think, are good in just about every system. Finally, continuous integration and deployment for ops code. So a lot of people use this for their applications code, but it should also be used for your ops code. So whenever you change the sysadmin or monitoring code, it ought to be deployed to a test cluster. Now, probably you'd have a few unit tests, and we do have unit tests for detecting the 800 different patterns of Perl errors. In fact, I have 800 tests because I knew I wasn't going to see most of them ever. And it would never work unless I had tests for all of them. And the state-saving stuff in our Nagios. But other than that, we don't really have that many unit tests. And this is, alas, very common. So the main thing you're watching for are bogus-looking alerts and emails from your cron jobs. It really sucks when you have a major cron job that has an obvious bug that causes it to always fail, get deployed to all 1,500 of your servers. That's a very bad idea. So if you're smarter than me, you'll have end-to-end tests, but at least you can watch for those emails, and then you can have this tested version be the one that you deploy to production. Sort of even more important is to get the testing philosophy. So continuous integration and deployment, typically the testing philosophy, if you ask the pointy-haired manager, hey, aren't you scared that you don't have enough testing? The answer is yes. On day one, you don't have enough testing. But after you've had a few failures, people started implementing tests for the things that failed. And so every time you have an uncaught error or poorly diagnosed failure in your cluster, you need to either write new monitoring code or improve your monitoring code. And almost all the examples in the system of stuff we monitor deal from real-life failures and not predictions of what would fail. So to sum up, hopefully this talk gave you a few new patterns which you'll be interested in using in your system. And I would love to hear additional war stories of interesting things or patterns that you know that are missing from my list, because I'm writing a book. So thank you very much. So we have a few minutes for questions. So in the aisle.
I've yet to meet anyone who does Nagios at scale who does not have the love-hate relationship that you mentioned at the beginning. So a tip and a question. My tip is that there is an open source package called CheckMK. That is worth looking at. It does three things in particular. One is the ability to aggregate multiple Nagios servers. So if you're running one Nagios server in each data center, for example, it'll aggregate that together into one dashboard. The interface is far superior to Nagios' web interface, in my opinion. Another one is that it will aggregate active checks. So instead of, it will send all 10 checks, basically activate all 10 checks to the server and then pull back the results. We see huge performance increase abilities there. And then the other one that it does, which we don't personally implement, is it does have some automated discovery of services and hosts built into it too. So definitely worth checking out. And my question for you is revolves around generating Nagios configuration files. When you talk about per environment, per data center, per application, per developer, et cetera, it gets out of control quickly. We're using a MySQL backend to generate that stuff, but we don't do more complex things like clustering, and I'd love to be able to do dependency trees and that sort of thing. Wondering how you deal with that. You know, magic bullet would be fantastic. I won't really expect it, but love to hear what you do.
So I would love to be able to say that I found this great open source package that allowed me to store all this configuration information and generate all these different configurations, because all the tools have to share, right? I have a tool that goes and does parallel operations to nodes, and I have a tool, you know, that I have Nagios, and I have this and that and the other thing. And what we have is a crappy set of codes that are driven by poorly designed YAML files, which essentially are the database. And all these individual tools generate, you know, configurations that go into all these different systems. I have yet to meet, and I don't think it exists, a well-designed tool that does all that. And even tools like Puppet, and nobody take this negatively, but even Puppet, for example, while it can describe nodes, I don't think there's a graceful way to integrate the way Puppet describes nodes with generating a Nagios configuration out of it. Sad to say. So maybe somebody will get offended about this and go off and fix it. It would be great. But alas, my solution is not one. I'd be embarrassed to open source it, right? Because the code's that crappy. More questions? Well, thank you all.